Hi, my name is Katie, and I'm the driver for the session, and I'm here with.
Hello, everyone. My name is Lauren, and today I'll be advocating session.
Okay, so we are covering chapter 16. I'm going to give a brief overview of what the chapter is about, and I'm going to go into the code. Um, so basically, chapter 16 was about. Let me just figure it out. My bad. Um, why? Saving objects in text. So here we are going over binary, serialization, and deserialization. I'm gonna go over that and then I will explain the code. So, what is binary data serialization? Binary serialization is the process of converting an object state, its instance variables, and reference objects into a component sequence of bytes, which is binary data that can be stored in a file sent over a network or held in memory. This binary format is not human readable. It looks like gibberish if opened in a text editor, but is efficient for machines in Java. This is done using classes like object output streams, which flattens the object's graph into bytes. What is deserialization? So deserialization is the reverse, taking binary byte stream and reconstructing the original object memory. Complete with this state, Java uses object input stream for this. The JVM allocates space on the heap and resource value and handles the reference automatically without calling constructors except for non-serialized superclasses. Different types of serialization. So while the chapter focuses on Java, both in binary serialization, here are common types, including non-binary for context. Um, Binary serialization, Java's object output stream. Default in Java stores the data as raw bytes seen in the chapter, game characters, for example. So we have XML serialization, XML encoder in Java or JAXB converts objects to XML text, human readable but large files, good for interoperability with web services, not which is not actually covered here, but it's good to know. Next, we have the JSON serialization using Kyson or Jackson libraries convert the JSON text popular for web APIs, lightweight and readable, not in the book as well, but it requires external libs. And then we have the protocol buffers or Avro external formats, binary but schema based for efficiency in big data systems, not Java native. Why are they good? Binary as in the chapter, compact smaller files, fast, less overhead. Automatic handles graphs without code, and it's secure for Java internal use. Harder to temper without Java, ideal for games or apps where performance matter and data stays within Java. XML and JSON, readable, editable by humans cross platforms, works with non Java apps, and flexible for evolving data structures, good for sorry, data exchange like APIs or configs. Lastly, we're going to know what the overall benefits are, and it just enables persistence, reduces memory use, for example, saves and reloads large objects, and it supports distributed systems, for example, send objects over to networks, drawbacks binary can break with class changes, hence serial version UID and non-binary formats may be slower and larger. So diving into the code, I'm just going to explain it and run it. So here we have our public class. So we have the private array list checkbox that just holds 256 checkboxes, 16 instruments, and 16 bits. The sequencer, this is the MIDI sequencer. The sequence is the MIDI sequence, and the track is the MIDI track. Here we have the instrument names and the corresponding MIDI code. So here we have the bass drum, the high tom, the vibra slap, and we can see the corresponding MIDI codes over there. Next we have the instruments as well, and this is where we will launch the GUI. here is the main window setup. So basically, when this just tells um, the title of the frame, and when the X button is clicked, it must close the window. Here we just have the background border, and yeah, we want to set the border. Next, we have the button panel. So the start, the stop, tempo, and the save and restore. Here we have all of them, as you can see that I just went over. Next, we have the instrument labels. So here we will show the instrument names, the instrument label, as well as the border and the box. This is where we add a panel to the layout. This is the grid for the checkboxes. This is where we initialize the MIDI system. Here's the MIDI setup. Here we build a MIDI track for the checkbox selection and start playback. Um, Here we just have our try and catch if anything goes wrong. This is where we adjust the tempo by multiplier. Here we create the MIDI events from tracklist, and then here is the utility to create the MIDI events. This is the save checkbox state to file, and here we restore the state from the file. So now I'm going to run it, and we should see it. So here we can see all the instruments, the buttons. So I'm going to click random and just hear if we can hear a sound coming out. And here's the stop button. And here's the tempo up and tempo down. Here's the serializer. And here is the restore. And that is it for chapter 16. Thank you for watching.